Okay, new idea. So let's take a situation and we're going to see if this statement makes any sense whatsoever. You fold a piece of paper. If you could, fold it 50 times in half. It would be thick enough to go to the sun. You're going, no way, right? So, your sheet of paper is 0.004 inches thick. All right? Have we folded the paper yet? No. No folds. We have a thickness. We folded once. How thick is it now? Think about it. 0.008. You double it, right? It's folded. One fold, second term. You hear the stepping stone idea again? Right? You're off by one. Third term describes how many folds? Two. How thick is the paper now? 0.016. Good. Now, we don't want to do this. Okay, we're going to fold the paper how many times? 50. We're going to get to what term? 51. Very good. Because there's one fold, right? We're to term 2 after one fold. Got to think about it, don't you? All right, now let's set up our spreadsheet to do the rest of this. So we're going to again set up our numbers. We'll put 1 here, and then we'll do equals, go up, and add 1. And we just saw we have to go down to 51. Look to the left. That just might help you. Oh, I forgot something. Let's go on to A1. And I think you can do this. If I do insert, how do I insert a cell? Insert, shift cells down. That's good. How's that? So I right-clicked on the box, insert, and then said shift cells down. Did you guys do that?
Yeah.
And what should go here? Position. Would it be the same thing to put fold there? If I put fold there, would that be the same thing?
Yeah.
No. Because 1 is what? No folds. 1 doesn't, the 1 and the number of folds don't match, do they? So let's do this. Folds. At the beginning, we have how many folds? 0. And then we'll do equals up plus 1, enter. Oops, what did I do? Equals up plus 1. Much better. So the number of the term, the number of the position, and then the folds. They don't match, do they? Okay. And then what should I put for the next one? Term's not bad. What shall I say for the story? Thickness. I was going to do width, but I like yours better. Thickness. Very good. Okay. And what's the beginning thickness? 0.004. Okay? Yes? Now, if I do this recursively, what do I do to get the next thickness? Take the one above it, and then times, which is above the 8, and 2. 1 above it times 2. 1 above it times 2. You hear the recursive nature? So let's do equals 1 above it times 2. Yeah? If I go back on here and go down, well, what happened? I messed up. Do the corner thing, go down to here, and we get these crazy numbers. Let's try something. Let's make this, you know how to make the column wider? Go up to the edge of C and just kind of go out here some. Now the E12 means scientific notation. It's like this bottom one is 4.5 times 10 to the 12th. Times 10 to the 12th. So it's like 4 and 12 zeros, inches. So let's see. That's the inches, right? How do I make feet? Equals, yeah, take equals, take these inches and divide by 12. And that's feet. How do I make miles? Equals, take the number of feet and divide by, anybody know? 5,280. Dude, we are talking about 71, see, 71 million miles. Maybe they're right. How crazy is that? Just 50 times, right? Okay. So the growth of this kind of sequence is amazingly large, right? Okay. Same idea. We have this old TV series called Star Trek. And then one show there was this thing called tribbles. And one tribble would become 3 the next day. Again, 1 day passes, second day. You see that? Again, they don't match up. 2 days pass, we're on the third day, because the first day nothing happens, right? What's the third day? How many tribbles am I going to have? 9. Fourth day, how many?
7.
Look at that. What did we do each time? Multiplied by 3. Okay? You get the idea of what this kind of sequence is about? It's different, isn't it?
Yeah.
But it does have a unique pattern. Got it? Let's go on. So we can answer these questions, but it's like, yeah, you're just going to get bigger and bigger and bigger, and we have to figure stuff out, right? And we need some sort of way to do that without making a long, ugly list. Because you want to talk about 500,000 tribbles? I'm not going to count those out. I have a life. Don't you? All right, let's go on. So go ahead and figure out these 3 patterns for A, B, and C. And again, feel free to move your desks and work together. All right, let's see what you got here. 3, 6, 12, 24, 48, 96, 192, 384. Good. B, how about that one? 250, negative 1250. Keep going. 6250 positive and
Negative
31
250.
250. Yeah, I'd say it the same way. Okay, and then the next one, 1/10. Now, I'm thinking this. You could do this because the next one's going to be what? 0.01. And now I see the pattern. I kind of like this one better, don't you?
Yeah.
So you're multiplying by something. So you're multiplying by 2 here. You're multiplying by -5 here. And you're multiplying by what? A tenth. Either 0.1 or 1/10 if you love fractions. Now somebody might say in C you're dividing by 10, and you'd be right. But if I want to say it consistently for this kind of pattern, we're going to say multiplying only. Just like for arithmetic, we always did what? We added. And so if it was negative, or we were subtracting, what did we say? Adding a negative, right? So that we could be consistent. Same thing here. Okay? So, what do we have in arithmetic? A common what? A common difference. How did I get that difference? I took a term and divided by which one? The one before it, right? So watch this. If I take this term and divide by the term before it, what do I get? What do I get specifically? The number. 2. If I take this term and divide by the term before it, what do I get? 2. The common division answer. But how about this? So I take a sub n and divide it by a sub n minus 1. Good. What do we call things that have bars in the middle? Fractions isn't bad. Ratios is what I was looking for, though. Equals R. Common ratio. Common ratio. So, it's geometric when 2 consecutive I should say any 2, my bad. Consecutive terms have a what? Common ratio. Very good. Or if you multiply by a common ratio, right? How are you doing? Good? In A, you can see it up there on your notes, right? Who is the first term? 3. How do I get any other term? Any other term? 2 times a sub n minus 1, the term before it. Right? Same kind of recursive idea. See if you can, either alone or together, do B and C. They're pretty quick. Let's do both at the same time. Who's the first term in B? Negative 2. And who's the first term in C? 100. In B, to get any term, I do what? Multiply -5 times the term before it. Okay? And for C, I take, to get any term, I do what? 0.1 times a sub n minus 1, the term before it. Okay? What's good, I hope, is you've done this now with arithmetic, so these come a little bit easier now in terms of what recursive means. Good, 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 good. Now, let's do A again. But watch. Who's the first term? In A, who is the first term? 3. What do I do to get the second term? Multiply by? What? 2. And we get 6, right? Who is this? The second term, right? What do I do to the third term? Multiply by 2 again. Who is this? Third term. What do I do? Multiply by 2 again. All right. Now, let's see. I want to get to any term. Now it is explicit. So then, in all cases, what did we do? Start with 3, which is, who's 3? A1. Okay, good. Times, who are those 2's? The common ratio, it's called the R. How many 2's or R's do I need to get to the fourth term? 3 of them, right? So whatever the n is, it's -1. Not an, be careful, right? See the difference? A sub n is the term. N is the number of the term. You see what I want here? All right? So then in B, who was the first term? -2. In, how did I get the second term? -2 times -5. How would I get the third term? Right? So then, oops, I forgot to do one more. So let's go back here for a second, now that I know what's going on here. To get the specific term in this list, it's 3 times 2 to the n minus 1. Good. You do B. It's easy. So here's the first term. -2. How big are the ratios? -5. And if I want to get to the nth term, how many steps do I take? Same idea of steps, isn't it? Right? Good. You go ahead and do C. Again with that 1/10 thing. Okay, so who was the first term in C? 100. How do I get the second term in C? Divide by 10 or multiply by a 10th. And then I take this one, that's the second term, I do it again, don't I? And so dot, 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 the nth term is 100 times n minus 1. Good. Okay. Now, for students who don't understand things and they want to memorize, here's what's going to happen. Some of you will put a plus sign in here because you'll confuse it with the arithmetic. Does the plus sign even make sense here?
No.
We're multiplying each time, aren't we? You see the difference in approach and how to study?
Yeah.
I want you to understand, not just memorize. Okay? So we got this already. We said that any term, if it is geometric, is what? The first stepping stone times the length of our steps, and we take n minus 1 steps, don't we? Right? Good, 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 good. So we're going to do these by hand. They're talking about a spreadsheet here to check your work. Would you like me? I'm going to do G. And maybe one more before that, but I want to make sure I do G. This kind of looks like the system problem, doesn't it? Remember that? Where we had a bunch of unknowns. Where's the bottom of the page? There it is. Okay, so here's what I'm going to do. Over here, I'm going to write A sub n equals what? A1 times r to the n minus 1. And again, I'm going to color code my work. Hope that worked last time. So A sub 9, which is a negative 1 over 128, right? That's the term. Do I know the first term? No. Do I know the r? No. But which term is negative 1 over 128? It's the 9th term. So then 9 minus 1 is 8. Everyone see where that 8 came from? N is 9. Then I take the red, and the 4th term is negative 1/4. Do I know the first term? No. Do I know the r? No. But if that's the 4th term, r is going to be to the 3rd. Good. Now in this system, what I'm going to do is I'm going to take the green equation and divide both sides by the same thing. What does this equal mean? They're the same thing, right? So if I divide the left-hand side by negative 1/4 and the right-hand side by a sub 1 r to the 3rd, I am dividing both sides by the same thing. You with me so far? I'm dividing one equation by the other. Now the right-hand side is not hard. What's a sub 1 over a sub 1? You divide anything by itself. 3 over 3, 7 over 7, 10 over 10. It's 1, right? In other words, it's gone. But I'm just going to write 1 here to show you it's math and not canceling. How many r's on top here? If you were to write it out. R times R times R. How many? How many r's here? 3. If you were to write it out, you see an R over R gone. You see an R over R gone. You see an R over R gone. How many r's are going to be gone? 3. How many r's are going to be left? Where? On top or bottom? On top. Now, that's how I teach math. You were taught subtract exponents. And either you remember it or you don't. I teach meaning, not method. Method, subtract the exponents. Meaning, r to the 3rd is r times r times r times r, right? R times r, right? And then you understand what you do with the r's. Isn't that better? You're not going to forget that. Don't you know by just definition that r to the 8th is 8 r's? You just know that. But you don't have to raise your hand. I'll bet you some of you forgot or weren't sure whether or not you're supposed to subtract exponents, right? Because those rules come and go. Brain just can't retain them for some crazy reason. That's easier, I think. All right, now, let's go back over here. Division. Is this the same thing? Negative 1 over 128 divided by negative 1 over 4. Is that this division? Yeah? And division becomes what? Multiplying by the reciprocal. What's a negative times a negative? Oops. Reciprocal, Mr. Murray. Is a positive. And then 4 goes into 4 once. 4 goes into 12 3 times. 4 goes into 8 twice. This is 1 over 32. what times what times what times what times what is 1? 1. What times what times what times what times what is 32? 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. What was the original question? Find the explicit formula and find the value of a sub 6. So a sub n is going to be, I have to find the first term. Any suggestions?
Well, we know R.
Good, we know R.
You can plug in any a sub n.
Yeah, so how about the red one? Nice and smaller numbers, what do you think? So R is a half. So this becomes negative 1/4. A sub 1, what was R again?
1/2.
We just found 1/2 to the third. And so I get negative 1/4. A sub 1 times 1/8. Multiply both sides by 8, right? What's a sub 1 going to be? Is that negative 2? And then R is a half to the n. There's our formula for this situation. I need to find a sub 1, I need to find R. And then I think they wanted the sixth term, so we just plug in 6 and work that out either by hand or with a calculator. Okay, I want to do the hard one so that you had an idea of how to try that. Let's go back now and do one more. Let's take this one. So a sub n equals a sub 1 r to the n minus 1. A sub 4 we know is 18. We don't know a sub 1, but what's r? 2. And what's 18? The fourth term. So in this case, it's easier, right? Only one variable is unknown. I should be able to solve for that. All the others, only one variable will be unknown. Just the last two, F and G, you'll have two unknowns and have to work with that system. Okay? So your homework is going to be finish this and the homework on the assignment sheet. All right?